I can't think of any funny way to introduce this one, so I'll just say it outright. You can draw with more than one texture at the same time. I'm sure at least some of you weren't expecting to hear that today. So, hello all you crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about shaders. So usually when you would draw something, whether this is in 2D GameMaker using just the draw sprite functions, or in 3D GameMaker using the vertex buffers, which you can also use in 2D if you want, you would specify a texture of some sort to draw. That could be a sprite, it's usually a sprite, it could be a font, it could be a tile set if you're manually taking care of drawing tiles. But generally you would only deal with one sprite or font or whatever at a time. When you start dealing with shaders, this does not necessarily have to be the case. You can load in more than one texture image to a shader at the same time, containing texture information about sprites or whatever you want. And after that, you're free to kind of do whatever you want with them. So before we start, this is where I would say shaders officially start to get kind of advanced. All of the things that I've done with shaders in the past have all boiled down to just manipulating either vertices, pixels, or both, just using math. But on the other hand, when you start to bring secondary textures into the mix, things start to get complicated very fast. So I have an empty room here. I'm going to go and create myself an object. It can just be called object1 for all I care. I'm going to assign just tree sprite 1 to its sprite, just so that I can see where it is in the room. I'm going to take care of drawing manually. Let's say go into the draw event, and we can say draw sprite. I'll go with draw sprite X so I can draw it at a scale, with a scale so that it's a little bigger. The sprite is going to be SPR tree 1. Subimage is going to be 0. X is going to be my X position. Y is going to be my Y position. I'll make the scale 4. No rotation. Blended to white and fully opaque. I'm going to explicitly draw SPR tree 1 instead of just the sprite that's attached to my object. I think it'll make things easier later. Let's see, I can also, do I want to make this full screen? I guess I might as well. Give me a little more room. So this is not going to do anything super exciting. We're going to just draw a tree on the screen. It's pretty elementary. We've done that before, probably. What I'm going to do next is I'm going to create a shader. And I'm going to call it, I should actually give this one a name since I'm actually going to reference it in code. Let's call it shader multi-texture. And I can, the default pass-through shader is good enough. I'm just going to move the curly braces onto their own line and get rid of some of the comments because these are no longer pass-through shaders. And when I go to draw my tree, I can shader set to the shader multi-texture. When I'm finished, I can reset that. And it's going to look exactly the same as before because all I've actually done so far is create a pass-through shader. Pretty much takes the sprite information and puts it on the screen as is without having to do anything special to it. So I'm approaching this video with the assumption that everyone who's watching it is somewhat familiar with shaders and what things like uniforms and other kinds of shader variables are, different data types, vectors, floating point values, and that kind of thing. If you're not, I've made a bunch of videos on shaders in the past. I will have a link to that on the screen right now where you can go and catch yourself up to speed. The videos in that playlist about 3D lighting aren't directly related to what we're doing here, although they do provide a lot of practice for thinking about how shaders work and how the values inside them work and what the inputs and outputs ultimately are. So even if you're not interested in 3D, they may have value to you. Other background information that you're going to want to know is how textures work inside the computer. Things such as sprites and tile sets and fonts are useful abstractions for images when you're drawing stuff in GameMaker so that you don't have to deal with how the image information is actually stored inside the computer. But when you start to do weird stuff with shaders, knowing how those work internally is going to be immensely helpful. I also made a video on just an overview of textures, which will also be linked on screen right now and also in the video description. It should be in the playlist of shader stuff that I linked a minute ago too. But that video in particular is one that I want to draw attention to for anyone who is not familiar with how computers and GameMaker in particular actually stores image information to be drawn on the screen. So let's go into the fragment shader, shader_multi-texture, and let's create a uniform. And instead of creating a uniform that is a floating point number or a vector of floating point numbers or something like that, I am going to use a data type called sampler2D, and I'm going to give it a name. Other texture. So samplers, as you can see here, sampler2D, samplers are textures which are passed to the shader. You are all already familiar with one, and that is GM_base texture. This is the sampler texture that everything is drawn with by default. This is the sprite that you specify when you say draw a sprite. This is the texture that you specify when you submit a vertex buffer. GameMaker takes care of this for you so that you don't have to manually include a sampler for every shader that you create, and you don't have to pass that as a uniform every time you draw something. As you all know, textures are a 2D grid of images.
Hey.
There are a certain number of pixels wide, there are a certain number of pixels tall. Texture coordinates always range from 0 to 1, so 0, 0 is at the origin in the upper left of the image, 1, 1 is at the, whatever the opposite of the origin is, at the bottom right of the image, and everything in the middle of the image, everything in between is some value between 0 and 1 on the horizontal and vertical coordinates. This is how you use the base texture when you obtain the texture information about whatever sprite you're drawing. In this case, GM_base texture is the sampler image. That's the texture that you pass to the shader when you draw something. And V_V text chord is a vector2 containing 2 floating point numbers. Those are the texture coordinates for this particular fragment. They are obtained from the vertex shader via a varying variable. Say that 5 times fast. And it contains 2 values, somewhere between 0 and 1, which can be used to look up the exact color information that is to be drawn for any given fragment. And you can use any other sampler that you pass to the texture in exactly the same way. So before I do anything else, I guess I might as well just show what happens if you omit the texture2D GM base texture lookup when you set the fragment color. This is going to set the fragment color to just whatever the varying color obtained from the vertex shader is. Since we are drawing this sprite with C white as the color, it's just going to be white. If you were to draw it with C red as the color, it would just be a flat red. You can see there is a square on the screen, which is just nothing more than a rectangle of whiteness. If you know how the vertex shader and the fragment shader and the varying variables that go from one to the other work, this should not surprise you. As I said, GM_base texture is nothing more than a built-in sampler data type. These spaces on the end of the arguments to texture2D function always bother me a lot, like more than they should, and I don't know why. I get very antsy about my code not having white space where it doesn't need it. Anyway, this can be any other sampler2D that you want. So if you wanted to, instead of looking up the base texture, you want to look up the texture information on other texture, you could do that. And before anything of interest happens, what'll happen if I do that? I imagine I'm just going to see black, in other words, nothing. Okay, so we do actually see white, which I guess is the default texture that the GameMaker provides. Anyway, we need to provide this uniform to the shader. So we can do that similarly to the way that we would with a regular uniform. With a regular uniform that is a floating point number or a vector of some sort, you would say shader get uniform, and you would specify the shader, and you would specify the uniform name, which is often people pass like time as a time as a uniform or something like that. In our case, it's other_texture. This isn't quite how getting a sampler works in a shader in GameMaker. Instead of saying shader get uniform, you would say shader get sampler index, and this specifically returns the uniform information for the samplers. And then to actually give that a value, to give that a uniform value, instead of saying something like shader set uniform, and then there are a bunch of data types that you could give the shader as uniforms, you can say shader set texture set stage. Texture set stage is a function with a scary name, which kind of doesn't really give any indication as to what it does. But all it does is it takes a sampler index, which is, you should actually probably save the result of this function in a variable so that you can actually use it later. We're going to call this, I'm going to just call that sampler other, is the result of this function. So we are going to say texture set stage sampler other. And the texture ID is just texture information. You've seen this before. Sprite get texture, tile set get texture, font get texture, whatever you want. And you can pass it for example, a sprite image. So I'm going to go with SPR underscore tree2. And we are going to specify an image index, an image frame, an animation frame, whatever, which is 0. Because SPR tree2 only has the one frame. And it's a tree. So I'm going to run the game, and this is not going to do anything. Or, well, it'll draw the tree, which I guess counts for something. This is not going to do anything, and if you understand how textures work... So the reason that the same thing was being drawn is that these two sprites actually live on the same texture page. If I were to go up to Tools, Texture Groups, and look at what this actually looks like, can I preview that? Anyway, if I were to go into the debugger then, and look at what the texture groups actually look like, which it lives on, you would see, let's pause the game, debugger, window, where is it? Surfaces and textures, refresh the list, and texture 1, you can see that both of those sprites are actually stored on the same texture image. So as it turns out, SPR tree 2 and SPR tree 1, when you say sprite get texture for those, that function, the result of that function just points to the exact same location in memory. And when you try to draw the image using using one texture or the other, you actually just end up with the exact same image. Hey. Because the textures in this case are actually the same. So to get around that, what we want to do is use our old friend separate texture page, this little checkbox under texture settings. I'm going to check that on both of them, and I'm going to run the game now. And we will see that now something different is indeed going to happen, and that is that the tree that is not the one that we actually said that we want to draw in the draw event is being drawn. And that is because instead of looking at the base texture, which is the texture that the sprite argument, when you tell GameMaker to draw a sprite, looks up, that texture is not the one that we are currently drawing. We are instead drawing the other one. Okay, boy, isn't that exciting. We can draw one tree instead of another. It gets a lot weirder than that. So as you can imagine, you can use this texture information for pretty much whatever you want. If you wanted to, you could say vec for, let's call it base text color is going to equal texture 2D. And that is going to be gm base texture. We can also create another vec for called vec for other text color. And that can just be the result of the other texture. And if you wanted to, you could, for example, blend those two together. We can say something like, we can take the average of those colors. We can average them together, for example, using something like base text color plus other text color divided by 2.0. This is a tradition now, isn't it? Or just 2 point, because that is a floating point number in GLSL ES. And then instead of setting the end goal fragment color to the vertex color multiplied by the base texture color, you can say the fragment color is going to be the vertex color times the final texture color. So now things are going to start to get interesting. You can see that we are kind of drawing both sprites at the same time. They're kind of like... You can see the outline of one, but it sort of has the texture of the other. If you wanted to, you could refine that a little. So if you wanted to draw, for example, the shape of tree 1, but the texture, or the actual texture of tree 2, you could say final text color is going to equal, let's say, a vec4 of the base colors red, green, and blue, but the other text colors alpha. And I can get rid of that -2 there, that divided by 2 there. And now we're going to kind of have a masking effect. That doesn't really look like anything, does it? These trees are roughly the same shape. Tree 2 is a little bit bigger. So if I were to use the other trees color information, the other trees actual texture information, and the base trees... Hang on, what am I doing? What should that be? Other text color, dot red, green, blue, and base alpha. This will create more of a visible cutout effect. Let me find another texture that I can use that will be a little bit more adamant about its texture and shape being different. Hang on. I can go into... This will do here. This is a bit of a cloud texture. Let me click separate texture page once again and go back to the draw event, and I'm going to draw with the, let's say, the texture of SPR clouds and let's say the shape of tree 2. I'm going to rename this to shape, just so that it's less confusing. So I'm going to have to also rename the sampler in sampler get index in the draw event, as well as anywhere where it happens to be used in the actual shader itself. So we can also call the shape text color. So this should be a little bit more exciting. So what we are going to do is we are going to draw with the color information from the clouds, so the texture of the clouds, but the alpha, the transparency of the tree. So what we are going to see now is going to be a tree that is, or at least a tree shape with cloud texture over it. So that can be useful. There are legitimate uses for this in games that aren't like completely weird. Some people may prefer to use blend modes to achieve this effect. I am one of the weirdos who thinks you should use shaders for absolutely everything. So if I were to do a masking effect like this, I would probably use a shader. Hopefully by now you see what's going on here and you see how sampler uniforms are working. There is one more thing I want to do just for fun though, and that is to have what is drawn on the screen kind of oscillate between the two textures. So let's see, I'm going to define another uniform called time. Anytime you say the word oscillation when it comes to shaders, you should automatically be thinking of sine waves, and those usually come with a time parameter so that you can see it change over time. We are going to say uniform float time, and in the draw event, shader get uniform. Once again, I've done this in many videos in the past. Time is going to just be current time divided by 1,000. Current time being the number of milliseconds since the game has started, so divide that by 1,000 to get the number of seconds. And then, earlier in this video, I basically took the average of these two colors and set that to the fragment color. Now, instead of taking the average of the two colors, I am going to base that on time. Var is not a keyword in GLSL ES, it should be float. Time value is just going to be the, let's say, the sine of time divided by 2.0, or 2 points, plus 0.5. That's going to create a wave that oscillates between 0 and 1. Again, this is something else I've said many times in the past. If you ever want to visualize an equation for using shaders or in anything else, Desmos, the online graphing calculator, is of immense help. I'm not going to spend time going back to that now, however, because I think I've already beaten that to death. And let us calculate the color, which is the result of blending the two textures based on the time value. We can say vec4 time color is going to be, and I'm going to use a function that I haven't talked about before, and that is mix. If you're familiar with lerp in GameMaker or most other math libraries, which is linear interpolation, mix is just what GLSL ES chose to call it. It does the exact same thing as linear interpolation. It takes a start and an end value and interpolates between them based on some parameter. It works for most data types. It works for floats. It works for vectors of any size. I don't know if it works for matrices or not. That would be neat. Anyway, we are going to mix base, text, color, shape, text, color, and we're going to base that on time value. Time value, of course, being a floating point number between 0 and 1, which oscillates based on how much time has been passed. And then instead of using the red, green, blue of the base color, we are going to be using the time color, so we can see the color bouncing back and forth. So we're fading to the actual tree, we're fading back to the clouds, and back to the tree. That's interesting. The period is 6.28 seconds, otherwise known as tau. So again, this isn't something that you're going to use every day, but it does have uses if you want to blend between two sprites, if you want to have a flashing effect. And you don't want to have to draw, for example, multiple copies of both sprites with different transparencies. You can just do it in a shader like this. So, I would be remiss if I did not mention this. The terminology used for samplers is slightly different in the different shader languages that you might use in GameMaker. This is GLSL ES. If you're writing a shader in just GLSL without the ES, that is the OpenGL shader language versus the OpenGL shader language for embedded systems is what the ES stands for. Most of the time, you will be using GLSL ES because it's compatible with any device that you might try to build games for.
Hey.
Anyway, the terminology between those two shader languages should be more or less the same. The names of the keywords and the data types and the functions used for accessing samplers and that kind of thing. If you are writing a shader for HLSL, which is specifically for Windows, which does some other, it has some other features that you might use, the relationship between shader languages and your target devices is kind of a mess, and I don't really want to spend time on it now. But anyway, if you're doing that, the function for accessing texture data will be slightly different, and I don't remember what it is off the top of my head. It will be on the screen right now. That is the function that if you're writing shaders in HLSL and you want to use multiple texture stages. Anyway, let's switch that back to GLSL ES. Some other things you might want to be aware of, depending on what kind of device you're making your games for, you will have more or less samplers that you're allowed to use in any given shader. If you're making a game for Windows or any other desktop computer, you can have up to 8 of these. That would be the base texture counts as 1 plus 7 sampler uniforms that you specify. Different devices that you might try to make games for with different graphics APIs and different hardware capabilities may not allow that many. I believe on some older phones you're only allowed to have 2 texture stages, which would be the base texture and one other, and after that you wouldn't be able to. You can imagine something like an iPhone 5, which is probably a little bit more squeezed for video memory than a desktop computer. Having a lot of texture samplers loaded into video memory at the same time is probably not a good idea.
Hey.
There is an upper limit for uniform data, like uniform floats that you can pass to a shader as well, but it tends to be pretty high and not something that you would ever run into unless you're doing something weird. So in the shader languages themselves, you are allowed to use samplers, texture samplers in the vertex shader, which you could do various things with. GameMaker, at this point in time, when I'm recording this in the end of October 2020, does not allow that for reasons which I do not understand. I really wish they would, because it would allow you to do some interesting things in the vertex shader, or at least it would allow me to do a very specific interesting thing in the vertex shader, which is probably not worth getting into right now. Maybe if you're watching this in the deep future, that'll have changed. You can try it out, use a sampler in the vertex shader, and see if it'll actually work the way that you want it to. That is all of the warnings and caveats when it comes to samplers I can think of. I like to think the things that I showed in this video with multiple textures with multiple samplers is fairly interesting, but in reality, this is only the tip of the iceberg of the things that you can do with them. It is really common to use additional texture stages, not as color information themselves, but as modifications on the actual base texture that you draw with. Any material that you might think about using in 3D is going to use an additional texture sampler, not as color, but for something like a normal map or a displacement map. Toon shading, as you can imagine, makes use of this. If you want to write a palette swapping shader, you will be making use of this. I do eventually want to cover all of the fun things, or at least a lot of the fun things that you can do with texture samplers in shaders in GameMaker and elsewhere. So this video is kind of going to be required viewing for a lot of those things. But those are all stories for another day. I'm going to end it off here. If you want the code for this, as usual, there will be links in the video description to a GitHub repository containing this actual code and a bunch of other things that I've referenced throughout the video. I have a Patreon, so if you want to contribute towards these videos being made, there will be links to that in all the usual places as well. Otherwise, I hope you found this useful, gave you some ideas for effects that you can use in your games, and I will see you all later. Special thanks to Edward Holt, Indie Punch, Jason, and Zenith for supporting these videos. If you want your name in the credits or to hear yourself shouted out at the end, head over to the Patreon page in the video description to join the fun.